So this time we're going to use repeated applications, and that comes in handy because we either end up with the same integral or just something really nice to integrate that we can do straight away. So if I look at the first one, x squared e to the x, so usually if we have an e to the x, that's the one we're going to choose. I might do it under here. That's the one we're going to choose to integrate. So I'm going to integrate e to the x and leave x squared. So I've integrated e to the x, and when I differentiate x squared, I get 2x. So I've got this new integral here. All right, so again, e to the, oops, how do I get rid of that? Don't know why that's happening. Very annoying, there we go. Nope, still annoying. So I'll move over there a bit. All right, let's try again. So here I've got my e to the x times x squared, and then I'm going to do minus 2 lots of, we're going to do it again. So I'm going to integrate e to the x, leave the x, minus, I've already integrated the e to the x. Now I can differentiate the x and I'll just get 1. So I've just got e to the x dx there. So that is nice to integrate. So here I've got minus 2 lots of e to the x times x's, and then I've got, so here, just be careful, I've got minus times a minus. So this is a plus 2, and the integral of e to the x we know is just e to the x. So looking at all that together, they all have e to the x's in them, so I'll put e to the x. I'll factorize by e to the x, so I get x squared, I get a minus 2x, and a positive 2. All right, so that's A. So let's try with B. So again, this one, you could actually have a look at either. We're going to do, let's do cos x, and we can go between cos x's and sin x's. So here, if I decide that cos x is the one I'm going to integrate, so that's sin x, I'll leave the other one. So I've integrated sin x. Now I'm going to differentiate x squared, so I've got 2x dx there. So I've got x squared sin x minus 2 lots of, do the same thing, so, oops, so I don't want that bit. So I'm going to integrate sin x, so I'll get minus cos x, and leave that one, and then I've already integrated and I got minus cos x, so I'm going to change this to a minus, so minus cos x, and differentiate the x, so I just get a 1 dx. Alright, so what have we got now? We've got x squared sin x, minus, so that's plus 2x cos x. And then again, be careful here, we've got minus 2 times a positive 1, so I've got minus 2 integral of cos x dx. Okay, so x squared sin x, 2x cos x, and minus 2, cos goes to sin when we integrate. Alright, so that's our answer. Okay, nice and straightforward. So let's try log x all squared. Again, you can do these in different ways. One way, if you can't, we could separate these to log x times log x, but log x is hard to integrate. So what we can do is times it by 1. So if I times it by 1, I haven't changed its value. So now I can integrate 1, leave the other one, minus, I've already integrated the 1 to x, and then I can differentiate the log x squared. Hopefully I can do it correctly this time. So the 2 comes out the front, then I've got log x to the power of 1, then I go inside because it's a chain rule and differentiate log x, and I get 1 on x dx. Alright, so I've got x, I've got the log x squared. Here I end up with, I'll write it out, so I end up with x times 1 on x, so I've just got a log x dx here. Alright, so I can do the same thing again. If I just keep that there, that was a minus. Alright, so again I can just times by a 1 there, so I can integrate the 1, leave the log x. So I've integrated the 1, now differentiate log x, I just get 1 on x. Alright, so I've got x log x squared minus 2x log x. Again, be careful here, minus times a minus is a positive 2, so positive 2, and this is just becomes a 1 dx, so when I integrate I just get an x. So they all, we can leave it like that, they're all there, that's fine. Okay, hopefully that helps.